Hello everyone, this is Group 3's presentation, Geosphere of Higher Activity Radioactive Waste of Geodisposal. So, nuclear technology is applied widely in our daily life, like providing energy, treating illness, and using in the industries. But some wastes are high in radioactivity for many years, which could be a security issue. So, it's necessary to find a permanent solution about disposing this waste. And Geosphere is the basis of the Geodisposal. So we'll introduce the following parts. What is higher activity waste? Site selection requirements, safety management, limitation, and future.
Let's talk about the site selection requirements. The most important thing is safety. Should be safe for lives and for the environment. As we know, the high-level waste have high radioactivity and high spin field. So the geosphere should enable to isolate, prevent radioactivity from reaching the surface. For the site selection criteria, the site should be built below 200 to 1000 meter depth and should have suitable size of host rock and technically possible for construction, and also enough robustness of the entire facility.
In the UK, the higher activity waste intended for geodisposal are identified as these two items. According to the radioactive content, the higher activity waste are broadly categorized as heat-generating high-level waste, non-heat-generating immediate-level waste, and low-level waste. Besides, there will be some other potential wastes. However, the host rock environment is at risk for corrosion and evolution during storage and disposal. With geological time, radionuclides will transport to the surrounding geological environment, which will have been affected by the outlying fluid. In this case, the radionuclides are likely to dilute and sorption reactions with the surrounding rock.
GDF are designed to contain radioactive waste and to isolate them from the biosphere. The facility can be as deep as 200 to 1000 meters underground, with multiple barriers to contain the wastes. In GDF, after the waste was packed in metal containers, it should be situated in a suitable rock type and then be filled with cement buffer or clay buffer. And this barrier means a physical entity such as the waste form, packaging, the backfill, or the host geological formation all provide a safety to the outside environment. And a preferred rock property include impermeability to fluid, limited erosion, dissolution, leach rate, and solubility, and retention. The geological barrier should be deep enough to provide isolation of the waste from biosphere and from human over the long-term period. Besides, there should not be any geomorphological process like erosion and glaciation happening around the area. Lastly, the disposal environment should provide substantial physical separation from the biosphere.
Okay, now let's focus on geodisposal of higher activity radioactive waste regarding geosphere limitations. The first difficulty is complex modeling. The materials used for backfilling the repository can shrinkage or cracking, making it difficult to model the migration of radioactivity into the geosphere. The second is there may be poorly understood chemical and/or microbiological reaction or activity in relation to escaped radioactivity. Finally, we can't ignore the building deep repositories can destroy high-quality geological conditions, but research on this issue has shown that the local geosphere will recover from the initial disturbances within a few hundred years and will remain stable thereafter. What's more, in some parts of the UK, geological and hydrogeological conditions 200 meters or more underground will stabilize for 1 million years or more.